Hello, everybody. Welcome. All right, thanks for joining us, everybody. I'm Heather Spalding from UC Davis. And Sarah, I'll hand it over to you.
Great, thanks, Heather. Hi, everyone. My name is Sarah Souza, and I work at UC Berkeley Environment, Health, and Safety. And along with Heather, and I believe Nellie from Santa Barbara and Claudia from UCLA, who may be joining us, we were the hosts of the Field Safety Leadership Retreat that happened about 2 months ago at Lake Arrowhead, UCLA's Lake Arrowhead facility. And our speaker today, he had been on the agenda but was unable to join in person. But the topic, weather forecasting, in particular, in support of our field safety efforts and in the context of supporting our field research teams and outdoor staff, he graciously agreed to provide it via Zoom today. And we are recording it so that we can add it to the library of our training content for the field safety program. So with that, I do recognize some familiar faces that were there at Lake Arrowhead. It is kind of hard to believe that it's been 2 months since then, but I hope everyone's doing well. And then some other faces as well that are joining just due to the important content. So Dr. Andrew Schwartz, I'll introduce now. He is the lead scientist and the field station manager at UC Berkeley's Central Sierra Snow Lab. And he studies snowfall and snow pack and is cited quite often in the San Francisco Chronicle of one place that I see his name all the time, and many different media are looking at his data, and government agencies, research institutions. It's a very important long-standing data set that Berkeley has been supporting. Andrew himself has only been there for about a year. It's interesting, his research focus in particular is also looking at the impacts of wildfire and then rain on snow events, which I think in California is very timely and important. So his perspective, I think, will be helpful for all of us. So with that, I'll turn it over to Andrew.
Perfect. Thank you, Sarah. As Sarah mentioned wonderfully in her introduction, I'm up here at the UC Berkeley Central Sierra Snow Lab. And I was planning on giving this talk at the safety retreat a couple months ago, but I wasn't able to. But I just wanted to chat about how we do field work and how we can develop kind of a plan and strategy to make sure that goes as well as possible when it comes to our weather and being out in the elements. And as I was saying before, this is just a presentation on really keeping an eye on the weather, both the forecast and while out in the field, to make sure that we're able to work safely and efficiently out doing our various field programs and projects that we need to. So as far as my background, I have kind of done field work all over the place, from out in Australia, where I did my PhD. That photo on the bottom there of me standing in a snow pit was my PhD research, to also doing bushfire research up there in the top left and hail research on the bottom left. And of course, as you might imagine, keeping an eye on the weather forecast for all of that is particularly precarious, especially because the hail project, we had to go out and try to get samples of really big hail with our instruments. So we had to try to get there about 3 minutes before the storm did and have it hit these instruments that we were trying to deploy. So making sure that we were keeping an eye on the weather and the forecast was incredibly important. And then also, I've also done some various field program work here in the US, out on the Eastern Plains, not only in Colorado, but in places like Kansas and Wyoming on convective storms. So actually doing some storm chasing. So I've had a bit of experience in various different geographies, really developing like fieldwork plans and weather safety plans to make sure that we can kind of keep people as safe as possible while making sure that we actually get the work done. So I've kind of divided this up into a few different categories. The first being just discussing what will make a successful field program occur when discussing weather. And then I go on to talking about data sources and kind of forecast sources, and then forecast processes. And it's just kind of geared, it's very surface level stuff, this could probably be an all-day seminar. And so as a result, it might be a little bit of overview for some of you, but I kind of go over the best sources and ideas that we have currently. So to discuss the important elements of weather preparedness during a project, the first and foremost thing, as I'm sure a lot of us are aware, is having some type of safety plan, but having one particularly for weather is a really good idea. And this is, primarily so that we can agree with all of the project participants on what is the most important and make sure that that is identified within this plan and that everyone knows the various bits of information as far as weather safety goes. So, this includes contact info for all the different participants, potential weather hazards that could be encountered at the field site, conditions that are or aren't favorable for field work to occur. So, really outlining quantity and values rather than something that might be a little bit more subjective. Good weather is very subjective, right? So those conditions that are unfavorable there, contingencies if unfavorable weather is encountered, and then preferred sources of weather information and suggested personal precautions. Of course, clothing, sunscreen, things like that, so people don't get left out in the open. But that's really probably the most comprehensive and best safety plan that you can draw up, is something that includes all of those. As far as forecasting and weather monitoring go, you really need to identify a couple different people to do that, or maybe one person, depending on the project size. But that's a very important thing, because if you don't identify specific people, you might not get everyone agreeing on what the forecast is, and then you can kind of end up with disagreement and a little confusion there. And then, of course, with these forecast monitors and weather observers, you want a communication strategy for all participants, which is why that contact info is so important in the weather safety plan, is just to make sure that everyone knows what's going on, whether or not the project is going to continue, and what to expect if there is any inclement weather. And then finally, a weather emergency kit. And I'm really not going to address that one too much, but I'll talk about it a bit later on. So a lot of us know the geographies that we work in, but in case we don't, there's a few different areas that we can go to really look for data on the risks at a specific field site. Of course, being there in person provides a lot of information, whether there's a shelter on the site, if we're working places like ranches or on the plains, what are the types of occurrences of severe weather? How often does it occur? What is the type of exposure? Is this a mountain ridge? Is it being out on the plains where you can easily be struck by lightning? And then are there any features or infrastructure that could increase those risks? Tall metal towers for lightning, rivers for flooding, dense forest for fires. And then how many potential evacuation points are there? So, these are all things to take into consideration when really identifying weather risks with a field site. And again, being there in person is the best way to go. But in the event that you can't be, or you're looking for, maybe something you can't immediately see, the FEMA National Risk Index is a terrific place to find a lot of these risks on a county by county basis for the entire United States. And that's what those two images are on the right. You have the top image of the CONUS with, I think if I recall correctly, when I pulled that image, it was fire danger for each county in the area. And then when you click on a specific county, it'll actually give you this really nice readout that's on the bottom right of the risk score for these various types of issues. So cold wave, drought, hail, heat wave, they even have things like earthquake. But it's a really useful tool to look at. Now, the other thing too, before I go on, is nobody knows risk and weather risk better than insurance and real estate companies. And this is actually some of the people that we work closely with in the meteorology industry. At least in Australia, we worked very closely with a lot of insurance agencies. to do those types of risk assessments. So if you have a good county by county basis, but you're looking more so at an individual property, getting into the insurance and real estate assessments are a really good way to go to try to identify those weather risk issues. So now that we have the risks identified and what we need to be looking out for with a weather forecast, who needs to be responsible for monitoring the forecast and determining if this field work is going on? This is kind of my opinion, but I think it really is best. And that's that the PI or the project member in charge of safety is the ideal candidate. And that's because they're typically aware of more of the intricacies of the project, including the site itself, a lot of the activities, the instrumentation. And so they're going to be more akin to keeping an eye on how the weather can affect those things and identify any potential issues as a result. With that being said, it's always optimal to have more than one person monitoring the forecast. And this is something that I do on a regular basis when we're doing broad scale field work within the meteorological and atmospheric science community. Is we'll all go off and kind of do our own assessments of the forecast, whether that be just looking through a quick app or actually getting into the nitty gritty of the models. And then we'll convene and talk to each other about it. Because oftentimes you might miss something in the forecast that somebody else might consider an important piece. And so having more than one person monitoring the forecast is a good idea, because it can be really beneficial to develop and determine some of those concerns that may not be addressed by a single person. And then I'm going to harp on this. I kind of already have been, but even though we have, 1 to 2 people that are often tasked with monitoring these conditions, it needs to be communicated to everyone. And there are the boring forecasts that occur where it's going to be clear and sunny. And so when we get those forecasts, we tend not to pay attention to the updates, because ultimately clear and sunny updates generally mean a change in temperature. But it's really important that we focus on communication when the forecast changes, because we do get a little bit lax. We get kind of zoned out on paying attention to the weather risks if we see that nice and sunny forecast. And if it changes abruptly, not everyone may give it the attention that it deserves. So when we get those forecast changes, it is important that they're communicated. And that brings us to the best way to communicate effectively with all the participants. And of course, communication with the whole team is key. Along with a weather safety plan, making sure that that's kind of distributed and that all participants know the criteria for continuing or canceling fieldwork is of the utmost importance. And again, these need to be specific values or quantities. They can't just be left up to, we need light wind speeds. Well, what is light? So that has to be very specific in how it's drawn up. Letting participants know when they can expect updates on the forecast and plan for field work. One of the things that I found in my time doing forecasting, particularly when I was doing consulting back in Denver, is that my customers tended to really enjoy getting the forecast at the same time every day and would start to build their schedule around it. So if you can keep with that kind of scheduling and a little bit of the habit that forms around checking your email at certain times of the day, it helps keep people more informed for sure. Along those same lines, using the same update format each time. So the way that I generally approach this type of thing is do an overall forecast picture that might be, 2 to 3 sentences long, unless there's a big storm, and then it can be longer. Do 1 to 2 sentences on whether or not that poses fieldwork concerns and what those concerns are. And then another 1 to 2 sentences saying what the current decision or plan is. So this is a terrific way, sent out once a day at the same time to really keep everyone updated on whether or not you need to be expecting certain types of weather, or whether you need to be expecting on going out that day for field work or not. And I know it can be a pain to organize, especially in the age of privacy and things like that. But text messaging, I found, is still the best way of communicating the forecasts. and any fieldwork plan updates. Everyone is next to their phone. Not everyone's going to be checking their work email or their student email on a regular basis. And some people are starting to shift away from social media. So text messaging is still definitely the best if you can do it that way. So now that we have, kind of our basis for operations, at what point do you cancel field work because of weather conditions? And I think it's no surprise to anyone in this group, really, but that's when the safety of the project members or the assets involved are jeopardized by the weather. And that's when it should really be reconsidered or canceled. Generally, it should be canceled. There's special circumstances when the project may need to be reconsidered. But ultimately, it comes down to everyone's safety. Nobody's life is more important than data. So if there's anything, even in the weather conditions, like on the right-hand side of this image, where you're traveling through a lot of winter weather, that needs to be taken into account, even if you're going to a field site that may not be experiencing that winter weather. So again, every project's going to have different cancellation criteria, but that needs to be well-defined, and there should be no room left for interpretation. An example here I like to give is fire weather conditions may be high if we have temperatures greater than 90 degrees Fahrenheit, winds greater than 20 miles per hour, and humidity is below 40%, we're not going out. And it's a single sentence, but it gets the job done, and everybody that looks at the forecast then knows what to compare it to. And so that's a really terrific way of making sure that the cancellation criteria is dry and easily understandable without being overly detailed, right? And you realistically, you're not always going to meet all of your cancellation criteria with weather. It might be that you have high temperatures and low humidities, but there aren't any winds. And that's when you kind of have to come back and discuss as a group the best course of action. Maybe you're going to be working in a more open area where there aren't as many fuel sources if a fire does start, or you have easy access to evacuation roads. Might not be as big of a deal as if you're working in a heavily dense forest where you have many ignition sources. But that's just some of the things that kind of have to occur is this specific criteria and then discussion depending on what the forecast is, if it's kind of borderline. So with all that said, we're going to move on to sources of forecasts and weather information. And I think one of the most frustrating parts about being a researcher working in a different country or another geography is, or I should say, not forecaster, but scientist or researcher working in one of these areas, is just not knowing the best routes of weather information. And so I've often found that the best way to do this, and I've spoken to my colleagues too, and we've kind of agreed that even if you don't know specific colleagues in the region, if you reach out to them and say, hey, I'm going into XYZ area to do some field work, can you tell me where I should look for weather information? Most of the time, they're going to send you some information that you can then use to find the forecast. And so that really helps in unfamiliar geographies. That said, Google searches are really easy to do as well. And most countries have their own governmental weather services. And these are generally more reliable than their private counterparts, of course, because they're held to a higher level of accountability. So, the UK Met Office is one of those. The Japan Meteorological Agency is another one. Generally just typing in a country and meteorology government or something to that effect will get that done. With that said, sometimes it's just not easy to find weather information in the region you're going to. And in those specific instances, you can consult social media. I generally don't recommend it, and I think anybody in here probably just doesn't agree with it necessarily either, but there are occasionally really good weather pages on Facebook or Twitter. And generally, just searching the various social media pages for whatever region you're in weather will bring up some results. A caveat to that being Mark's Fantastic Weather Emporium is not always a good resource. Make sure you're doing your due diligence and checking the credentials of the forecasters if possible. there's telltale giveaways on how good some of these websites are. If you see a lot of those weather buzzwords in the top, in that image on their page, chances are you're not going to want to depend on it for information, because they're looking to get clicks and views and all that type of stuff instead of actually informing people. So, and in all fairness, the Weather Channel is kind of guilty of this at times too. But realistically, anyone with moderated wording and a thorough discussion is somebody that you want to check on. And if all else fails, check the plots and images that they're using for watermarks or logos, because oftentimes those plots will take you in a better direction for the forecast and in a more informational direction for the forecast. Since we're pretty California centric and US centric in terms of our field work, I do want to highlight the National Weather Service. I'm sure none of you are probably strangers to the National Weather Service for one reason or another, but they are such an invaluable tool, and I don't think people realize just how many different services they offer. So the first thing I'm going to really suggest is knowing the office for your fieldwork location. Down around the valley here, just west of where I am on Donner Summit, it's the Sacramento office. A little bit to the east of me, it's the Reno office. But these are called the weather forecasting offices, and there's a variety of them throughout the country. And it's important to know because they issue these wonderful forecast discussions. So that image on the right-hand side, if you go to weather.gov, it will bring up this nice little bit of information, the detailed forecast, they call it, which is kind of not really all that detailed, but enough. But underneath that, if you go to additional forecast and information and click on that forecast discussion, that is a forecast that is actually written by one of the lead forecasters at those offices. The detailed forecast is actually spit out by an algorithm from model data. So there's no interpretation on it, and it's going to change pretty frequently compared to the forecast discussion, which is written by an actual human. So that's one of the areas I go to most when I'm looking at severe storms here on the summit for snowfall or wind or fire. And realistically, it's the best tool that you have when looking at your local forecast for your sites. I can pull one up right now. I don't know if I'll be able to share this screen. I'm going to hope. Let's see here. Can you guys see that?
Now we still see your slides. Maybe if you hit Alt-Tab, that might tab between windows.
Yeah, I'll pull that up real quick. There we go. That should be better.
It's still sharing your slide. Sorry.
Oh, you're okay.
I think, oh, there you go. We can see it now.
Cool. So these are really nice because they give you an overall synopsis up at the top. Just, kind of, again, if you're poking in to check on what the forecast is and see how much has changed, this is a really good place to start. The discussion, on the other hand, gets a little bit more in depth. You start talking about how many clouds you're going to get, wind speeds for various times, temperatures, and then a little bit more of the weather evolution overall. And then you have the extended discussion, which realistically is up to a week out. And also with ever increasing UAV use and drone use, one of the benefits of using this forecast as well is that they have an aviation discussion at the bottom. So they'll talk specifically about wind speeds around here and various little things that may impact aviation. And that's a really good spot to go to for drone issues and things of that nature. So that's just an example. And these are done daily, I think actually multiple times a day by the various offices that run the weather service, excuse me. So if all of that fails and you're not getting the information that you need, you can actually call the National Weather Service offices for additional details, and they will patch you through to one of their meteorologists. With that said, I would strongly advise against calling like 3 to 7 days out and asking what specific temperatures or wind speeds or thunderstorms are going to be occurring, because they'll probably chuckle a little bit and they'll say, well, I don't really know. I have a good idea, but that has yet to be determined. So they'll help you, but they're only going to give you the amount of information that they have at hand. And they're definitely not going to help anyone make decisions on their field work, of course, because that's a liability to them. But with that said, those forecasters are a terrific, absolutely terrific resource if you want one. So to this point so far, we've talked primarily about daily conditions. And if you want a higher resolution forecast, maybe you're hoping to do field work in the morning or in the afternoon and want to know what things look like, another great resource from the National Weather Service is what are called meteograms. And I'm going to pull this up and successfully share my screen this time. There we go. So when you come to the National Weather Service page, and I hope this works because earlier this morning their server was having issues, but you go to wherever it is you're looking for your forecast, perfect. And then you see this wonderful extended forecast, the detailed forecast that I had a picture of. But down here on the bottom right-hand side is the hourly weather forecast. And these are what we call meteograms. So when you click on this, it'll actually give you a bunch of different variables that you can look at. Sky cover, which is really nice to tell you how much cloud cover to expect, precipitation potential, but it'll give you this likelihood throughout the day for the next several days. So temperature, wind chill, wind gusts and wind direction. And it's not the prettiest thing in the world, but it does have plenty of good information on it. So you can even get, the likelihood of seeing lightning and thunder out of this forecast or snow and rain. Unfortunately, these bottom ones are bare for where I am, probably bare for where you are too. But, in an optimal situation, there would be some type of nice looking bar plot here with how much rain we're going to get. So these meteograms are immensely helpful, particularly when you're looking at specific framing of times on field work days. So that has focused on the National Weather Service. And as I mentioned before, these types of offices exist for many different countries. I used to work with the Bureau of Meteorology in Australia a lot. They have a lot of similar products. Meteo France, of course, the Japan Meteorological Agency, they all kind of have the same products in one way or another that are incredibly useful like that. So if all else fails and you are heading out of country, definitely keep an eye out for those governmental websites. So moving on to kind of specific hazard forecasts, of course, average daily forecasts are nice for determining, kind of generally overall whether you're going out. But if you want to keep a close eye on severe weather and make sure that you're not out there when that's occurring, this is the best way to do it. So when it comes to convective weather, which is, just basically thunderstorms, there's a lot of hazards that they present throughout the United States at various times of the year, like hail and flooding and tornadoes, of course. And the best resource to really go to for these is what's called the Storm Prediction Center. And that's another office of the National Weather Service. So they focus entirely on hazardous weather and storm weather. And they generate these wonderful outlooks that are oftentimes graphical, like the one on the right, where the light green are areas that are likely to experience some type of thunderstorm. The darker green areas are areas where severe thunderstorms might become an issue. And then the more alarming colors, yellow, orange, red, are where severe thunderstorms, become increasingly likely, and you have to look out for things like hail and tornadoes. The nice thing about the Storm Prediction Center is because they're so focused on hazardous weather, they're continually updating information throughout the day, whereas at the individual National Weather Service offices, they kind of have skeleton crews, so they're not able to get out the information quite as quickly. So if you go to the Storm Prediction Center webpage, they'll have a plot like this. You can look at the rough percentage of calculated for like the exceedance of severe hail and things like that. And they'll do what are called mesoscale discussions, where they'll talk about specific areas of development and timing and things of that nature that are very, very useful. So, of course, with anything like severe weather, we need to take into account several important considerations. And with this type of convective weather, luckily, we don't have too many of them here in California that occur on a regular basis compared to like Oklahoma or Texas. But, lightning is a big concern, especially when you're exposed. Hail size, we did have a bit of a laugh in the meteorological community recently, because for the first time, at least in recent memory, the National Weather Service put a warning out for hail the size of DVDs. So, little hail, pea-size hail, that's one thing to deal with. But if you have CDE-size hail flying at you, at the very least, you need to make sure you have a car that you're willing to damage, and and hopefully you're not going out on days like that anyway. But of course, flash flooding is also an issue and can cut off routes to get back out of field work. Tornadoes aren't quite as much of an issue, but that they are something to be aware of when you're working out on the plains. And then this is something that I hammer on a few of these slides, but the road network. What are the escape routes? If you find yourself in some of these hazardous weather situations, there always has to be a good escape route. And when that doesn't happen, it kind of ends up, you can end up with serious injury or even fatalities. And El Reno, Oklahoma in 2013 was a perfect example of this, when Tim Samaras, Paul Samaras, and Carl Young, who were fairly famous tornado and severe storm scientists, were killed by a tornado when the road network that they were on wasn't sufficient to get out of the way of the storm. So with any of these specific weather hazards, there always has to be multiple escape routes, or at least a substantial network to help you get away from them if they do occur. Now, of course, this is assuming you're going out on these days anyway, which probably isn't the best idea, but sometimes you just have to make concessions and hope for the best. And, it's best to be prepared than not. So when we move on to wildfires, the nice thing here is same source of good information, the Storm Prediction Center. They give general fire weather conditions, though. They don't, really start talking about specific areas, as you can see in that image on the right. They have elevated fire weather, critical fire weather, and extreme fire weather. And luckily, we're not seeing any extremes yet. But this is just saying, is condition right for big fires to develop? With that being said, I actually tend to prefer working or looking through the information of agencies like CAL FIRE and other state agencies, because they tend to monitor existing fires and then also discuss the areas of highest concern for developing fires. Oftentimes they do these discussions of even specific, mountain ranges and things like that. So it's very useful. And then in the condition, or in case you don't get your fire danger information before you leave for field work, of course, the Forest Service has plenty of local info at all of their offices, as well as their little fire service signs that they have at the side, or fire danger signs, that they have on the sides of the road. And again, some important considerations: road network and evacuation routes. Again, red flag warnings. I'm sure we've all heard this term and are aware of it, but they're issued for weather events that may result in extreme fire behavior that will occur within the next 24 hours. And I think this is a fairly good explanation of what they are, but as kind of a further point on them, some of these forest fires that develop have what are called spotting. And I've got that listed as an important consideration here too. And that's directly related to wind speed and direction and fuel sources, which are also important considerations. But the scary thing about these red flag days is that the fire fronts don't move in a predictable way. They get up into the tops of the trees and form what are called crown fires, and can develop fire spotting up to 6 miles ahead of the main fire front, when various pieces of burning debris are actually blown 6 miles ahead of the main front and start other smaller fires. So generally speaking, if it's a red flag warning day, I don't do any work and try to hold off, because even the smallest spark can really cause some issues, not only for the safety of the people in your field site work, but also for anyone else downwind if it so happens that you're the one that causes the spark. So, those red flag warnings are not to be taken lightly whatsoever and should definitely be paid attention to. So dust and air quality. I know for us recently, this has become more of an issue, especially with our fires. And I've kind of broken this up into a couple different things. First of all, forecasting. Airnow.gov is a fantastic website that consolidates forecasts from smaller air quality agencies and links the agencies together for more information. So they actually take these individual forecasts that occur at like local EPA offices, whether that be here in California or in places like Atlanta, Georgia, and they put out the current conditions as well as what's to be expected in the future. They also do some really great analysis on what the specific things are that are affecting the air quality. Is it primarily pollen? Is it primarily dust or smoke? They do some really great work with that. And then they also have resources related to current wildfires and smoke that's occurring. The other nice thing about airnow.gov is they have suggestions based off the air quality index. For those of us that can't remember, is 100 on the AQI enough to make me stay inside, or does that start at 200? They'll post the forecast and say, any type of activity outdoors isn't suggested at this time. So airnow.gov is a terrific one. Private weather companies like the Weather Channel and AccuWeather are starting to offer these air quality forecasts with their normal forecasts. But they should be used with a little bit of caution because so far they don't actually correlate very well with what's seen on the day of. I think they might be a good, very general bit of data to just determine whether it'll be good or bad. But other than that, they probably shouldn't be used too much. In terms of monitoring air quality, purpleair.com is an absolutely fantastic website. And this is what a lot of us use here in the Western US for determining where the biggest plumes of wildfire smoke are. I would imagine most of us have heard about it, but if not, if you haven't yet, it's basically citizen science project that has gone absolutely massive. So you buy these sensors online for $200, $250 and install them within range of Wi-Fi at your house, and you get this wonderful dense network of air quality readouts that you can see in that plot on the right. And yes, you have the occasional outlier, as you can kind of see highlighted in red in those areas, but this is really the best way, at least where there's relative amounts of population, to determine where wildfire smoke and other air quality hazards are currently existing. Obviously, if you're doing field work out in the middle of Nevada, it might not help you that much. But by and large, Purple Air is a really good one. And then, of course, as I mentioned before, airnow.gov is as well. Moving on to winter conditions and avalanches. This is something that working here in California and on the western side of the country, we have to deal with a lot. There is a lot of different things to take into account when working in winter conditions and avalanches, so much so that it could probably be its own presentation. But again, this is just to kind of give an overview. So one of the things about winter weather is because it doesn't affect all of the United States on a regular basis, oftentimes the best resources for it are going to be state specific. So in terms of travel and road conditions, this is pretty self-explanatory, but the State Department of Transportations like Caltrans or UDOT in Utah or CDOT in Colorado, those are the best ways to go and really keep an eye on things. And then, of course, there's a little bit of broad scale avalanche information out there. I think avalanche.org is a good example of that. But state-specific forecasting centers are generally better because they have a better handle on their terrain and on their recent weather conditions. So looking into places like the Sierra Avalanche Center, who are up here near me in Truckee, or the Utah Avalanche Center is going to be better than and maybe those national sites. If you're heading out into the backcountry and just want to know what weather conditions exist, or what snow conditions exist, I should say, I would really suggest using this USDA NRCS, which is the Natural Resources Conservation Service, SNOTEL, which is a snow telemetry site. And there's about 850 of them in the Western United States, and they are in very remote parts of the country. So chances are there's going to be one around the site that you're working at if it's in the Western US. And they have fantastic interactive charts and recent data that you can examine for things like changes in snow depth. Maybe, going out into the backcountry, you're okay with up to 4 inches of snow, but once you get 4 to 8 inches, you don't want to be putting people in that amount of physical strain. And using the SNOTEL data is a really good way to do that. And recently, the NRCS has made a big push to make this even friendlier for people who aren't in the hydrological or meteorological fields. So they're starting to develop interactive charts. They do have strict areas where you can download recent data. And most of these are updating at least on an hourly basis, with occasional measurements that come out daily or things like that. And as I mentioned, they're out in the middle of nowhere. So they're a fantastic resource if your field sites aren't anywhere around civilization. In the event that you don't have a SNOTEL site around fieldwork locations, then this National Weather Service National Operational Hydrologic Remote Sensing Center, which I think is a title much too long, but is really good for their remote sensing work. So they're doing this a lot based off of radar and satellite data. And you can see an image on the right-hand side there of what this type of product looks like. And this is actually 24-hour snow accumulation ending at 12 UTC today. So, it's not such a big deal for us here in the spring, but if you are concerned about how much snow your site got in the winter or potential travel conditions, this map's a really good way of determining where that might be issues. And then, of course, wouldn't be one of my specific hazard forecast slides without important considerations. Of course, travel is probably the big one here. But with winter weather, temperatures and wind chill are a huge issue, particularly because they don't, weather patterns in the winter don't follow the same kind of diurnal patterns that we see in the summer. Generally in the summer, we have peak temperatures around 3, 4, 5 p.m. But we can actually get decreases in temperature throughout the day in the winter when we get strong cold fronts that move through. So keeping an eye on those temperatures and wind chills is a really important factor. And then avalanches and tree wells. Everyone needs to be going out in a group. Of course, avalanches are incredibly dangerous. People need to have their avalanche beacons, their probes, avalanche shovels. But tree wells actually claim a fair amount of lives too. And it's something that not many people think about. But, there's these little areas of decreased snow that build up around tree trunks that skiers and backcountry travelers can fall into. And if they're by themselves, have been known to suffocate people, and deaths have occurred. So, in this type of situation on the bottom right, where this skier was fortunately found and unburied, and was all right afterwards, I should mention, it's important that you're always in a group, because this type of situation on your own is almost a death sentence. And it's something that not a lot of us consider when we're going into the backcountry. So those are all really specific forecast sites and specific areas of data for hazards. But sometimes you want a basic forecast. And there needs to be some discussion about when it's okay to use basic forecasts, such as those that I find on my Google phone every day, rather than anything from the National Weather Service or those more specific hazard forecasting areas. And these types of apps are fantastic, but there's a caveat to that, and that's that they're algorithm generated from raw model data. So kind of similar to what National Weather Service posts on their extended forecast. And so as a result, when the new weather models come out, which is generally 1 to 4 times a day, these forecasts change. So they change kind of in rapid succession, and there's no differentiation between perhaps a bad model run and a good model run. Whereas, with the National Weather Service discussions, there is that ability to distinguish between the two because you have a human forecaster there. But with that said, these do have a place. If there's no immediate danger posed to life or property by conditions, if you're just generally looking at minimum and maximum temperatures for the day, maybe a little bit of how cloudy it's going to be, these are great. Just driving down an hour from campus, if it's not in a remote region, fantastic. They're really good for determining whether conditions will be favorable for UAV or drone operation. And then they can be used to ensure that sensitive samples aren't being taken outside of preferred temperature ranges and things of that nature. But with that being said, there is that caveat that they do perform a little bit oddly, particularly in days further away because of that, because they are algorithm generated. So safety concerns and emergency contingencies. If I have to be entirely honest, the primary safety concern, I think, with weather and the forecast is variability and uncertainty in that forecast, especially at fine scales. And so there's kind of a trade-off that we have here, that you can either have decent weather forecasts for about 2 weeks, but they might be on a very large scale, or you can have really accurate forecasts for about 18 hours at a very fine scale. And I'm not going to get too into that. I'm just going to say it's because of computing power, and we don't have quantum computing yet for our weather models. But as a result of that, it can lead to complicated decision making in the field. So, when going into the field and you're not necessarily sure about the forecast, I do suggest that you take a NOAA weather radio, especially if thunderstorms are in the forecast or fire weather's in the forecast, because a NOAA weather radio will immediately alert you to any type of severe weather or hazardous weather event that's going on. And they have signal in many, many different places. A Kestrel, which is that little image of the yellow instrument on the right. These are fantastic. They cost about $160 each. That yellow one, I think, is the one that I have personally. And they're terrific for going out and getting wind speed, temperature, relative humidity, barometric pressure, just about anything you can imagine realistically from that little sensor on the day of field work. So if you are debating about whether or not it's favorable and you go out to Kestrel, it can really help narrow it down. And then again, having a weather emergency kit, hopefully you never need to use it. And the one that I've put in here on the right is a kind of a road/car emergency kit, but they contain a lot of the same things, additional food if you get stranded, depending on the type of weather you're experiencing, maybe a fire blanket if you are having to go out on hazardous fire days. It really just depends, but having that type of kit available with fresh water and all kinds of good things like that is super important. And then, of course, as I'm sure you are all well aware, being dressed for the conditions is one of the best tools that you can have in the field too. But inevitably, there will be some type of weather that interrupts your field work or someone's field work that is problematic. And so it's important that we have contingencies in place in that weather safety plan that says, if a fire starts and you see smoke anywhere in the vicinity, take these routes to get away from it. If X weather or severe event occurs when in the field, do Y. And that's all it needs to be. And again, that needs to be highlighted on the weather safety plan and discussed with everyone participating. Where this can get a little bit muddy is if there are specifics, if there's a specific evacuation route that's more favorable, it can be a little bit hard to remember as participants. And so ultimately, it's good to have a paper copy of those contingencies when you're in the field in case of inclement weather. So the forecast and planning process. When should we first be examining weather forecasts and how should we be monitoring it or checking it? And, the atmospheric spatial scales are kind of the spatial and temporal scales, I should say, are kind of the golden rule for this, at least for us in meteorology. And this really just shows the spatial scale on the x-axis on this plot on the right to the temporal scale on the left. And so if you're worried primarily about when a cold front's going to come through, you're going to want to be looking at changes that occur, of course, on the scale of days, because fronts are roughly that size here. Whereas if you're looking at microscale turbulence associated with like aircraft operation or things like that, you're going to want to look at as short of a forecast window as possible, because it is a smaller phenomenon and it's going to change very, very quickly depending on the rest of the forecast. With that being said, those smaller atmospheric phenomenon like thunderstorms, turbulence, tornadoes, those the forecasting on those gets much, much better as you approach the day that you're heading out into the field. Those are not much better. They're pretty bad up to about 3 days out, and then 1 to 3 days out, they get better. And the best way to really think of this is just starting with a top-down or large to small scale approach. Really start looking 10 to 14 days before the field day for a good indication. And then start looking at smaller things like how much the temperature will change with your cold front as you get closer to the date, because that's when it's going to get better. And then ultimately, we've talked about this a little bit, but forecast variability may mean tougher decisions and more frequent forecast checks. And that's likely the case. So I've created a quick forecasting flowchart here. And this is kind of the process that meteorologists use both at the National Weather Service and in their personal lives when they're interested in the weather. But at 10 to 14 days, and again, this doesn't have to be looking at weather models. It can just be looking at the forecast from the National Weather Service. But at 10 to 14 days, getting a general idea of the potential weather. Is it going to be clear or not? You can't really determine specifics at this point. But the main thing here is it should be used to determine how closely the forecast needs to be watched. If at 10 to 14 days, you see a lot of snow or rain in the forecast, then it's a better idea to start watching the forecast more regularly. At 7 to 10 days, the general weather pattern will become clearer. You're going to start to see differences in temperature, wind, and precipitation quantity that are somewhat reliable, and when things are going to impact various regions. And I would say at this point, you start to check the forecast every 2 days at 7 to 10 days, because anything more than that is just going to be you driving yourself crazy, because the forecast will still be quite variable. At 3 to 7 days, the weather pattern will have likely been determined. You're going to start to see better specifics, but timing and location may still be a little unsettled. You might see differences of timing on the order of a few hours and location on tens of miles. So again, temperature, wind, your variables that you're interested in are going to be getting better, but they shouldn't be probably relied upon to make any solid decisions yet. At this point, if there are unfavorable fieldwork conditions, really checking the forecast every day to see if they're changing is a good way to go. 1 to 3 days out, accuracy of the forecast improves significantly, and timing and location of the weather is pretty spot on, with a few caveats to that here and there, particularly in complex terrain areas. But if the forecast at 1 to 3 days is still looking variable, checking twice a day may be a good idea. And the model runs that we have as meteorologists come out at 0Z and 12Z, so midnight and noon in England, and generally take a few hours to come in. So here in California, I tend to look around 9:30 or 10 in the morning, and then roughly the same time at night. And then that's when you start making preliminary decisions on whether field work will occur. And again, if it says sunny from day 10 to 14 all the way to day 0, then a lot of this isn't necessary. But, if weather's looking a little bit more unsettled, then it needs to be paid attention to. And then day 0, I really suggest everyone take a look at the forecast the morning that you're headed out, if not the night before, because it's going to be the most accurate, and you'll get all the best details on the variables that you're looking for, and then you can make a decision on whether to conduct that field work based on that information. So we're getting pretty close to the end. Again, this has kind of been general, but there are some really terrific resources if you're looking into maybe deciding how you decide whether or not to go out. The University Corporation for Atmospheric Research, where I used to work, has a program called METED, and it's basically a collection of all these wonderful lectures and presentations. Some of them are interactive from the people doing the research and the forecasting. And you don't have to be a meteorologist. You can go in and say, how do avalanches work, and they'll have a presentation that you can go through and figure it out so that you can make those decisions better. So I really highly recommend that one. The College of DuPage Next Generation Weather Lab is another fantastic resource. If you click on weather analysis tools when you go there, they have all sorts of different products that you can look at that are quite easy to navigate through. I wouldn't suggest really getting heavily into the models if you don't want to, because they can be confusing. But one of the best things that they have are what they call their text products. And they take, and you can click on a region. I clicked, for instance, on this bottom right-hand side on California, and it has statewide National Weather Service regional discussions. It has specific regional discussions for like Sacramento and climate reports and things like that. And they're continually being updated. So that's something just absolutely terrific out of College of DuPage. So with all of that said, the general recap for optimal weather preparedness is fairly simple. And I think things probably most of us have realized, but it's always nice to reiterate them. And that's, having a weather safety plan that includes contingencies and that is communicated to people, really identifying who the weather monitors and observers are and how they get their data is something else that's important. And then an agreed upon weather monitoring process. It is really important to have whoever it is monitoring the forecast sync up and make sure that they're looking at the same things, or maybe even different things at the same time, but making sure that they at least have a plan to come together and discuss that. And then, of course, communicate that to the team, which is number 5. And then in an absolutely worst case scenario, having that emergency kit is a good idea. Something I didn't mention during this whole presentation, but I think is very important, is if you are in a team of more than a few people out in the field, having someone actively monitoring the weather by sight is super important. I was in Crested Butte in Colorado a few years ago, out in some aspens doing some work, and my colleague and I happened to catch the development of some thunderheads off in the distance just from looking at the sky that we weren't expecting. And if we had noticed any later, we probably would have been running out of the forest trying to avoid lightning strikes. So once you're out in the field, having somebody that's, has at least a partial job of keeping an eye on the sky is always a good reason, good idea as well. So with that long-winded presentation, that's it for me. Hopefully it was of some use.
Thanks so much, Andrew. That was really informative. There's actually a number of sites there that you mentioned that I wasn't aware of. So I definitely took some notes, and Just for everyone's awareness too, we'll share these slides, we'll post them so that you can have access to those and some of those links as well. Let's open it up to questions. Does anyone have any questions specific for Andrew to answer? You can either type it in the chat, or you can unmute yourself and speak up. We're a size here that I think we can just let people ask questions directly if you'd like.
If you have questions, I'll try to work out my camera situation too.
Great. How much snow is that in this picture right here at the snow lab? That last picture you're.
As soon as you said that, I changed it.
Yeah, this one. How much snow? I mean, I've seen those towers without snow, and so I'm guessing.
This was in December. That little black and white gauge over there is probably 10. Oh no, that's the amount of snow on the ground right here is probably about 12 feet, 12 to 13 feet.
I was thinking that you get into a lot of confined space situations, and a picture that you show that you can drop in a hole. Would it be advisable to give people an confined space awareness orientation? And also, I think in the kit you had some lanyards and things like that you can have on some of these approaching a confined space. At least you have something attached to you that can prevent you from going all the way down. I don't know the situation, I'm not out there, but just an observation.
Yeah. I think as far as falling into a tree well, probably, I guess you just, I think you'd be moving around so much that I don't know what you'd tether to stay out of falling further down into the hole. And the snow will stop you. So I think probably more important than tethering would be to make sure that people had shovels with them. They make very lightweight snow shovels that you can purchase. And that would probably be a better idea, because the snow itself will stop somebody eventually. It would just be more about having to dig them out at that point. Jimmy, I see your message in the chat. As far as foreign regions, again, I would do my best to look for governmental agencies in each area to try to get data from them on what you can expect as far as the forecast. I guess for weather info in general, if you don't have any other choice, using something like a zip code or coordinates on weather.com or some of these other weather websites may be as good as you get, because it is algorithm generated, but at least it's something. But with that said, I would really suggest you reaching out to, one of maybe the country's weather agencies or a colleague in that area.
Andrew, I have a question. Who needs a weather safety plan? Is this something that everybody needs to have as part of their field safety plan, or only people working in severe weather conditions?
Realistically, I mean, I think, the weather safety plan is something that is more important for the severe weather conditions. But, if doing the work depends heavily on even something like specific temperature range, it's not a bad idea to have. It may not have to focus on contingencies and things of that nature at that point. But maybe, at least including it so that what ranges of temperatures are optimal and whether or not people should expect to go out on a specific day, depending on those, the current conditions. The other thing too is, and I didn't really mention this, but clearly if you're a single person going out to do field work, you probably don't need a field safety plan because you don't have anyone you need to communicate it with. But with that said, it's still pretty important, I think, for anybody with a larger group of people.
Andrew, could you just speak a little bit about the term atmospheric rivers? Because I feel like I've been hearing that a lot. And is that a technical term or is that more of a sensational term? Because I feel like the storms that we've had recently, they got labeled that, did quite a bit of damage. Just the amount of rain coming down in a short amount of time, trees falling, mudslides, all of that. Is there information on assessing, where we're going to be within the storm approaching? Any tips I think would be helpful.
Yes, so atmospheric rivers, they have become a bit more buzzwordy lately, but they've always been a thing. Realistically, depending on where you are on the West Coast, they actually give us about 50 to 60% of our moisture. And they're a phenomenon that exists around the world at all types of mid-latitude. So the West coasts of most continents see them, including South America and Australia and things like that. But there are, to your point, Sarah, various degrees of landfalling atmospheric rivers. And Scripps has a rating system that they use to determine how impactful it would be. That would have been a really good slide to add to this. So I'll have to put that in my suggestion box for the future. But yeah, so Scripps has a rating system that they use for these atmospheric rivers, with a 5 being a maximum, kind of the maximum for an event that you can expect flooding and landslides and damage. And we actually had one of those come through this last October, which brought us all that rain and caused some issues here in the mountains. But, I think a rating of like a 1 is just enough to bring in a little bit of rain. And maybe, if you hydroplane, it's a safety issue. But other than that, it's not such a big concern. But with that being said, if there is a forecasted atmospheric river making landfall and it's going to be in the area that you're in, you do have to take into account things like landslides and potential flash flooding and those types of hazards as well. So I would say, best resource for those when you start seeing people talking about an atmospheric river, if you're planning on field work, is definitely Scripps, because they are the best at identifying the hazards associated with those. Did I get all your question? I think I did.
Yeah. Thank you.
There was a question that came in ahead of time about climate and false news on climate. Like, how do you kind of interpret or deal with that kind of misleading information?
Yeah, misleading information on climate's always an interesting one. I guess there's a number of different ways you can kind of take it on. But it also depends on the source. If it's somebody that you can sit down and have a genuine conversation with that doesn't necessarily have the best background and doesn't have the best knowledge on climate change, and it is false knowledge that they have or fake knowledge that they have, finding common ground to discuss that with them and finding things that they're interested in that climate change might pertain to is a good way at kind of counteracting some of that false narrative that's out there. A good example is, there's a lot of people that really love to fish and hunt that may not be thinking about the impacts of climate, but you can kind of get them on a conversation. What have you noticed in your 30 years of fishing at this area? Have you seen any changes? And then before you know, you're both talking about fishing and maybe being able to discuss climate in a way that's constructive and getting rid of some of those other areas of fake knowledge or bad knowledge, I should say. So that's one way to do it. As far as combating like broad scale misinformation and disinformation on climate, it's just important that we all get together to have a loud voice. The bigger the collaboration and community that's behind making these changes and understanding it, the more we can impact. So.
I also had a question that came up. I know I'm dominating the questions here, but anybody jump in at any time. When you were talking about bringing weather radio with you to the field, some of our researchers are working in the remote backcountry. They might be backpacking in and have to be really conscious about the weight that they're carrying. How big is a weather radio compared to, sometimes they'll bring a satellite communicator like an inReach and text someone back home for weather updates.
I mean, in those types of situations where weight is incredibly important, and adding any additional material onto your back is a recipe for disaster. If you have a Garmin inReach or something to that effect, and you are able to get somebody back at the lab or at the house to give any information on the weather, that's probably going to be a better route. With that being said, I use an inReach on occasion in the backcountry, and I know they can be slow to update. So, if you can make a weather radio happen, that's terrific. If not, then, the inReach should be just fine, as long as that person on the other end is actually monitoring for updates.
All right, well, maybe we'll wrap up then. Thank you for answering all those questions. I'll give out one last shout out. Anyone have a last question?
Last thing I want to ask you, you said that some people go with a team, some people go alone. So if they don't have to have a weather plan, what other precautions a lone person should take?
I guess it depends on the level of activity and the level of risk that they're taking. If it's a single person, doing some field work that's relatively close to a populated center, then it's not a big deal. A lot of the work that I do up here on the summit, and that I do with a few of my colleagues, even if you're going out on your own, you do a safety risk plan and share it with people so that you can check in with them. So, if you're going into the backcountry on your own, then using a safety weather plan, or maybe just doing an addition of a weather plan to your risk assessment, is a good idea. Specifically so that anybody that's keeping track of you while you're in the field can make sure that they're aware of what your movements are and what your plans are if weather does occur that needs to be addressed. So, it really depends on the amount of risk being taken. I would tend to err on the side of caution and add that into any risk assessment that I'm doing as it is. But again, if you're driving 5 minutes around the block, it's probably not as big of a deal. So.
All right, well, thank you, Andrew. Really appreciate your time and learning more about these resources that you utilize and that are available to all of us. And I know that Heather and I listened to, I think it was more of a podcast actually from the National Weather Service out of Reno that was giving some forecast updates as well. But I wasn't aware of that little forecast discussion button on the page either. So that's a really simple thing that I learned from this. And hopefully people will take advantage of that and access information that maybe I find weather pages to have a lot of detail, and it's a little unclear until you click on things, what's behind them. So it takes some exploring. So your insights are incredibly helpful to all of us.
I'm glad. I get just as lost as you do, I promise. That's why I was like, go click here.
Yeah, the explicit instructions are very appreciated.
Yeah, and if anybody has any further questions, feel free to reach out. I'm always happy to help where I can. So.
Absolutely. Thank you again. And like I said, everyone, we'll post this onto the field safety training website. I could share the link once it's up to all the participants. I think Heather has that roster. And feel free to reach out to us if you have any suggestions or follow-up questions.
Perfect.
All right.
Yes, thank you again.
Thanks, Heather, and thanks, Sarah, for setting this all up.
You're welcome. It was great to host this. Thanks, Heather, for doing the details and logistics. All right, everyone, have a nice afternoon.
Thanks, guys. Bye.
Bye.